Okay, Assalamualaikum warahmatullahi wabarakatuh. So now we proceed. We are still in the introduction to the chromatography. So in this video, I'll be more focused towards the type of the chromatography. Okay, so basically there are a few types of the chromatography that you have to go through in detail. The first one is absorption, and then we have partition, size exclusion, and ion exchange. So that's why I said when you are decided to use the chromatography, so you have to look at your application and then try to match with the type of the chromatography. Okay, for example here, when we talk about the adsorption chromatography, you know that the word of the adsorption means the sorption happened at the surface. Okay, so for example, you have the stationary phase, okay, and then you also have the mobile phase. So your aim is to separate this compound. So you have a several compound. So basically, when we talk about the adsorption chromatography, so usually all of these compound will be adsorbed at the surface of the mobile phase. Sorry, at the stationary phase. Okay, only happen at the surface. And then after a few minutes, okay, when you look at the chromatogram, so there will be a few peaks appear, and then you know that from here, for example, if the peak of the triangle is occur first, so you know that it will be having less interaction with the stationary phase, right? And then, for example, you have the second one. For example, this octagon occur at the second one. So you know that the interaction between this analyte with the stationary phase is in the middle. And then the last one, for example, you have the oval analyte. You know that it will be retained more in the stationary phase because it has more or strong interaction with the stationary phase. So that's why it will be occurred last. So this is the one that we talk about the adsorption chromatography. An example is, for example, you have a column chromatography. Okay, so the analyte will be going throughout the, we call it as a silica, silanol, which is silica-based stationary phase. And then the one that have the dissolve like dissolve with the stationary phase will be having longer interaction at the surface of the stationary phase, and then the one that have less interaction will be coming out first from the system. Okay, so the next one, we talk about the partition chromatography. So basically partition chromatography, it will be related to the partition coefficient. So you are quite familiar with the partition coefficient. This is the one that you already learned through in detail in the solvent extraction, right? Okay, for example, you have a stationary phase, and then also you have a mobile phase. So usually the mobile phase is a liquid, except for the gas chromatography, you are referring to the gas, for example, right? And then in the stationary phase, you have the solid surface, but in the solid surface, you have a liquid stationary phase. So in this, we call it as the situation of the chromatography. So you have the mobile phase, which is liquid, and also the stationary phase is also a liquid. So that's why we talk about the partition, because we have to look at the concentration of your analyte in the stationary phase, and then you compare with the concentration of your analyte in the mobile phase. Okay, and then our aim is to separate these two compounds. For example, this is a very simple example, and then the one that you obtain here is the gold oval analyte coming out first as compared to the purple one. So why? When you try to make a conclusion, so you know that the partition coefficient of purple will be higher as compared to the partition coefficient of the yellow. Why? Because when we talk about the partition coefficient, which is the concentration of your analyte in the stationary phase over the concentration of your analyte in the mobile phase. Okay, why purple coming out later? Because it has higher concentration in the stationary phase. We'll be having stronger interaction, retain longer in the stationary phase, and then it will be coming out later. Okay, so that's the partition coefficient. So usually partition coefficient is applied for the HPLC, for the GC, right? Because you are comparing the partition between the mobile phase, which is liquid, and also the stationary phase. Okay, when we talk about the size exclusion, so this is a very specific application when you are having the analyte which is which are you are having analyte that have a different size in terms of the size. One is smaller and one is bigger. So you cannot go for the adsorption and also partition because this is more towards the size separation. Okay, so usually when we talk about this one, you have a stationary phase. Usually stationary phase made from a membrane or the one that have a pore. Okay, the pore means it have a several size of the membrane. Okay, so how is this one is separated? So it's quite easy to understand. So as we can see here, the smaller one will be going into the pore of the membrane when we talk about the stationary phase. And then the red one, because it didn't fit in the pore of the membrane, so that's why towards the end, the red one will be coming out first. Why? Because it didn't going through into the pore of the membrane. As compared to the purple one, it will be going through into the pore of the membrane, takes time, so that's why it be retained more in the stationary phase. Okay, so this is how size analyte separated in the size exclusion chromatography. And then you have another one, which is ion exchange. Of course, this is based on the ion. Okay, when you are dealing with the acid, amino acid, there are several ions involved. For example, positive and also negative. Okay, for example here, the mobile phase, which is of course the solution, flow of the solution to bring your sample throughout the stationary phase. And then you have the stationary phase that made from the, for example, positive charge. Okay, and then our aim is to separate positive and also negative analyte. So this is quite easy to understand. When you are having the stationary phase which is positive, so automatically the negative analyte will be retained more because it will be having interaction with the positive stationary phase, right? And then the positive one, because it will be repelled to each other, and then it will follow the mobile phase to going through your stationary phase. So that's why, okay, when we look at the chromatography, the positive will be coming out first, right? Because it doesn't have any interaction with the stationary phase. And then how about the negative? So it will be retained more because it will attract in the stationary phase. Okay, so vice versa, if you are having the stationary phase which is made from the negative, right? Okay, so I think that's all for the type of the chromatography. So you can go through the lecture notes in terms of the detailed explanation and also in terms of the difference.